hello and welcome from my side. Good morning, I guess, to the folks in the US, and good afternoon to those at EMBL. And so for today, we decided to have a presentation actually about the EMBL Imaging Centre, which is the newest service unit at EMBL that is now getting opened, I guess, very soon. Timo will say a few words. And it's devoted to bring basically the latest high resolution imaging technologies, so both electron as well as light microscopy, to the scientific community. And this is, of course, exciting also for our community here, because it will include a lot of custom developed methods that are not yet really commercially available. So the center is being led by two team leaders, one for the electron microscopy side, one for the light microscopy side. And so for the latter, EMBL was very lucky to recruit Timo Zimmermann for this position. So it's our pleasure that he's with us today. And I want to say a few words about him. So Timo studied biology in Munich with a focus on electron microscopy. And he then did a PhD about confocal microscopy in both cell and developmental biology. He then actually came to EMBL and joined the advanced light microscopy facility here in 2000. And I guess this is where he got in touch in the first time with, how to run a facility, and he gained very valuable experiences there working on multiple advanced microscopy applications. And he then moved from EMBL to the Center for Genomic Regulation Barcelona in 2007 to actually set up a light microscopy unit there. But then he returned back home to Heidelberg 1 year ago, now with the goal to set up the light microscopy service at the new EMBL Imaging Centre. And so with this, I would hand over to Timo, and maybe I would also ask you about how you want to have the Q&A being done, whether you are happy to be interrupted or whether we should leave this to the very end. But yeah, thanks again, Timo, for agreeing to speak, and the screen is yours.
Thanks, Robert, for the introduction. Thanks, everybody, for the invitation. Actually, I'm really excited to be able to talk about this. Maybe just a technical question first. Maybe we can wait until the end because interruptions, I may not really see that. If somebody just wants to speak in, I don't mind, but I cannot really trace things. It might be that I don't see it. So if it's maybe rather in the end, it would be fine. I hope my connection is good. I'm not talking from the imaging center, so that's not the data connection. I'm actually right now in Finland next to a lake. So I just hope it's fine. Okay, with that, I'll share my screen. Welcome, everybody. The topic of the talk is probably a bit unusual given the format of this seminar series, although it's quite wide-ranging. This is maybe a technical talk in a different manner. So I'm not going to focus on single technologies. I would rather like to show what for me and hopefully for others is a very exciting new project. I hope it is relevant in that it tries to connect technology to the end user, and I hope this model is as a set of interest. So with that, I'm starting. So you already see the first image. So the imaging center is, of course, a building, and I'm going to talk about this quite in detail. And what I want to do is I want to shortly introduce a little bit my motivation and a bit of an outlook. And then I want to talk quite a lot about the building specifications, because I think they are of shared interest, and it's, I think, quite unique that one is able to deal with a building of that size that is specifically set up for a purpose that is aligned with your research interest. So that's something I do want to cover, and it's maybe something that also could be politically relevant when planning major undertakings in other places. I want to then go into the operation planning, basically into the business model, and time allowing, I would then maybe conclude with some considerations of the operation, because I think it's a fairly new concept, which is different from many services that are in place. And that's something I try to cover in the end. As Robert was already saying, I left EMBL quite some time ago, and I actually went to a place that I really, really liked. So as you can also see from the images, the Center for Genomic Regulation was in a very nice location, and I really enjoyed my years there. And I think I would have been quite happy to continue there for a long time. But something fundamentally changed at EMBL, which really caught my interest, because I think it goes way beyond any kind of service unit that I could have sort of operating. So I was really quite excited by the concept. And I returned to Heidelberg to the EMBL Imaging Centre recently to actually oversee the putting into operation and then the start of operation, which will happen still this year. Just shortly, the EMBL Imaging Centre should cover access to the latest light and electron microscopy technologies. So this both focuses are on imaging, and at the highest possible level, we all know that these fields are moving very, very fast. And to be at the forefront, I think a lot of flexibility is required and a lot of support that actually allows to follow the field as it is developing. And the idea is, and that's already something I will talk about more in detail when I talk about the operational model, will be a full and tailored project support by expert technical staff. What this exactly means, I'll try to cover more later, but it is a very integrative model of service provision. I think we have all seen that you cannot necessarily offer technologies by training the users. They become more and more complex, so you have to have business models or operational models that allow you to work together with the user on their project. And there's also, we hope we can bridge the technology gap, both for developments coming out of academia, as well as cooperating with industrial partners, of which we have actually already quite a few, in the effective commercialization of new imaging technologies. And as you will also see, this could also be a hub for training activities for new technologies, as there's also infrastructure for that. Just as a short overview, I will get back to this more later in the talk. So it should be a unique infrastructure. Just to give you a little bit the scope, it is a major undertaking. I mean, it's a very large area, 6,000 square meters. The building has really been built up with care, with funding by the Ministry for Research and Sciences, and also the state of Baden-Württemberg. And in addition, it will host technologies in both fields, light microscopy as well as electron microscopy, which of course also are costly and which will need a lot of support. This is what we want to make work. And to connect this, and especially connecting this for external users correctly, you need, of course, a lot of processing power and also the ability to then transfer the data in a way that is useful for the end user. So you see, it's a really big budget and it's a really big project. And that is, of course, also what attracted me. Maybe one thing that you see here, which is a bit strange, is a funder or a sponsor or a supporting company, Heidelberg Cement. But you will see in 2 slides why this actually is quite relevant for us. And of course, we have already, as I said, industrial partners. So Leica, Zeiss, Aberio, Thermo Fisher, that are providing instrumentation at the latest edge of their portfolio. And I hope that this cooperation will continue to be very successful in the future. So just to start with, you see that the imaging center here as an overview has 3 layers, 3 levels, and it has a quite huge area of 6,000 square meters. And just to give you a feeling for what it means that a center is built or a building is built with imaging in mind, I'm now going to tell you where these 900 cubic meters of, or almost 900 cubic meters of concrete actually went, because they went into a base plate in the level 0. So in the level that you see on the left-hand side. So it's a 27 times 27 meter block of concrete that was poured in one go, which is the foundation of the main light as well as electron microscopy rooms, which you can see here. And you can also see that the electron microscopy rooms for the big cryo-electron microscopes actually most floor. And you can really see, this for me is in a way the center of the building, how this defines the purpose of the building. I illustrate this here with images taken off that main structure. So these are the cryo-electron microscopy rooms for the big cryo 300 kilovolt. And you see the size of it if you're just on the top floor. You see the extent. And I wanted to show this because it shows the level of dedication that went into this. Now, if you talk about electron microscopy applications, of course, cryo applications are becoming more and more important, and are the foundation of also the resolution revolution that we're currently experiencing. And cryo preparation, cryo operation requires control of humidity. And you can see here that several rooms are, for example, kept at 20% humidity, are optionally for 10% humidity. So we have here rooms on the light microscopy side that can be that are at 20% and are optional for 10%. We can just add dehumidification, or that are actually for the preparation rooms operated at 10% on both floors. And we have, of course, further rooms that can be connected to the 20% dehumidification. So there's a lot of possibility to accommodate cryo applications in a very flexible manner. This in a way is shown here. Again, I show you things not to brag, but I think it's really exciting to think about what it means to really dedicate a whole building for imaging. So this is the structure or the technology that is behind the climate controls and the control of the building. And you see it's a pretty big space, I think almost 400 square meters, that is really full of the equipment that is actually needed to provide the temperature stability for the whole building, to provide also the humidity control with two separate air conditioning systems, one at normal humidity and one at 20% humidity, which then can further be dehumidified. As far as instrument rooms and spaces go, there's a lot for light microscopy. So I just kind of like earmarked instrument rooms on the main base plate, as well as in other rooms that can be used for microscopy development, for microscopy service operation, also in conjunction with our industrial partners, and also for open innovation in conjunction with industrial partners. So there's quite a lot of rooms available that we are now slowly beginning to fill. There's a lot of EM space for multiple systems that are concentrated around this main axis, as I was telling you. And there's a lot of preparation space for light as well as electron microscopy as we are needing it. In addition, also, of course, storage space. So it's really a whole building centered around this. Just to show that we are starting to fill it, I show here some of the instrumentation we have already in place. So a MinFlux, a self-built super resolution single molecule localization microscope, and a STED for the EM side. There are, of course, already light microscope, electron microscopes in place. So at size crossbeam scanning EM with cryo stage, a Glacius 200 kilovolt electron microscope, and also you see here still in the early stages of the setup, which was some weeks ago, the Titan Cryos, which is in one of the main microscope rooms that you saw before marked on the map. And in addition, we of course also have the full support structure in the form of wet labs as well as tissue cultures and storage areas. Another thing that I wanted to show is planning for the future as soon as we really get going. And that is to also take into account the different biological safety level or biosafety levels that we will have to deal with. And you see that just by the way it is constructed, so actually there's doors here and here, a whole area of the light microscopy part can be a dedicated BSL2 area, which is planned for the future. At the moment, it's not yet implemented, and it is also connected to a preparation space as well as a tissue culture. So we can fully separate it from the rest of the building in a way that allows us to work also with more complex and demanding organisms. And optionally, this can also be done for the electron microscopy part, because also there it is important. Now, another thing that is important is there's, of course, a technology part of the building, and there's a part for training and for outreach, a public area, which is in the middle floor on the lower side, as you see it here. And this contains, for example, an auditorium, as well as seminar rooms. And we have also, for further training applications, meeting rooms throughout the building. So several, I'm not showing all of them here. And in addition, you can see here a future exhibition space. So you see there's a very big empty space here in the middle. And this one will be filled with an exhibition on molecular biology and on imaging, which will also dedicate these spaces and will allow visitors to experience or to understand better what we're actually doing in the fields of research that we're doing. So the idea, especially with the auditoriums and the seminar rooms, is of course that this can also really be a hub for training and for training people, for exposing them to the latest technologies. Okay, this was about the building, and I hope it wasn't too long. I really thought it is important to maybe reconsider the demands that we actually have and that we are normally limited by. I mean, I've been setting up my own facility and I've been moving it inside the building. One works with relatively good conditions, but one rarely ever works with optimal conditions. I think we all have been plagued by problems with air conditioning, temperature control, leakages, all kinds of things which are really affecting, of course, the high technology that we're offering. And taking everything on board during a planning that already goes back many years, I mean, it goes back all the way to 2015, really shows in the execution of the building. What I want to do now is a little bit talk a little bit more about the operational model. So, since I already said access should be to the latest light and electron microscopy technologies, I can cover them a little bit more later in the talk. But to be able to provide support for complex experiments, we need an operation model that starts, of course, with the teams that we're actually setting up for the service. And I want to reiterate here, and this is a fundamental difference to the way that normally service units actually are being created. It is an external service. It is meant for users from all over Europe, from all over the world, in the form of open access. And this is different from, let's say, a core facility, which normally grows out of the internal demand and accommodates that and then extends beyond. And in this case, actually, the aim from the beginning on is different and is aimed to the outside, to user projects. And in this, it's maybe more comparable to, for example, the operation of a beamline than a classical core facility. But let's go through these. Two integrated service teams. So one in cryo-electron microscopy. This is headed by Simone Mattei, who you see here, and one in also advanced light microscopy. And you see that faces outwards, that should interact with the users as they come and onboard them, as well as then the teams of experts at the postdoc level that are the scientific service staff. So these would be engineers, both in EM as well as in optical sciences, microscopy application specialists as well, thinking about all the phases of an experiment, very, very important, more and more important, of course, image data analysts. I'm actually, maybe that's a very good venue to say so, I'm still looking for an additional optical engineer. So I will probably reopen this position, and I would be happy if this can also be, let's say, propagated by you, because these positions are quite hard to fill. I will still have to specify exactly the profile, but it would be good if this can be also communicated in this group here. So the idea has to go beyond what you can normally do in I would say, a normal core facility, where very often the focus is actually on the middle part, on the image acquisition. So you outsource the sample preparation and many of the demands there to the groups or the people that you're working with, normally internally. Then you help quite expertly with image acquisition. And very often, depending on how your facility is set up and how much manpower you already have to let go at the data analysis. I think a lot of work is happening to connect image acquisition and data analysis better, and this can only be supported. But I think very few core facilities can cover the preparation of the sample tightly with the user right through image acquisition, right all the way to data analysis. But this kind of integrated project support would be needed. It would be needed because the technologies that we are looking for, that we are going to offer, are highly complex and can probably not be understood fully by the people that would have the best use for it. And also they are aimed not at internal people, where you could generate some kind of training regime that brings people up to speed, and you can focus more and more maybe just providing the service of the acquisition. But it should allow people to come with a complex question, be helped in preparing the sample, as well as then going through the image acquisition and then to the data analysis. To be able to do this, access is very important, and we will have several access modes, which will be the direct access, which we are right now setting up, and in which So we will deal not in the form of booking instruments per hours, but by basically evaluating projects and then providing access as needed by the project. And this will be evaluated by external referees. And of course, also open access doesn't mean free access. They have to contribute to the maintenance costs of the microscopes and to the running of their experiments in a model that is, of course, becoming more and more common, that you have to be able to recharge research networks, research infrastructures. And this will also be relevant for the imaging center, so that one can provide access, for example, for structural biology researchers through and also through funded access schemes of which the users can connect directly to the imaging center through these networks. For the Eurobi imaging, we are currently working on integrating the image center into the EMBL node, which is already existing, but of which we are not yet a part. But these are strategic considerations how to open yourself actually to the people that you want to get in contact with. What I think is very important is, and where we should be quite uniquely positioned, is to close the gap between technology development and the scientific impact. So I think this is something we all experience, that of course a new development is not immediately available to everybody. It is not, it's just a matter of accessibility. The group that develops it can normally not share its expertise and knowledge efficiently, and the technology is then taken up by more and more experts. At some point, it is also receiving the interest of a company, and then a commercial solution is being developed. But this means that because of commercialization of all the facts or all the and training, the scientific impact is can be quite remote. I mean, we've seen this a little bit with light sheet microscopy. I'm again seeing that my connection is unstable, where I would say the gap between the first implementations at EMBL and the first release of a commercial system were around 8 years. So this technology gap and how to bridge from the classical core facility concept, the EMBL Imaging Centre can bring the scientific impact closer to the development by very, very dedicated service provision. And this is really the point of the teams as we are setting them up, to connect the users to the instrument at a time when this normally would not be possible because of the high degree of dedication that is needed. This should also be relevant for example, internal developments. And I mean, these are just now examples of potential groups that are developing new technologies at EMBL for whom this could be relevant. So the imaging center should work very, very closely with the developers, with the researchers, and create something of a win-win situation where the developers can focus on really providing new technologies and maybe cooperating in targeted cooperations, but don't have to, for example, put effort into providing access to their technology. If one can work with them efficiently together, this kind of access provision can actually come through the imaging center, where the service teams for light microscopy as well as for electron microscopy can establish the service and provide it, so that you can take custom systems, adapt them for service, and provide this without putting this effort into the developer groups, who can then go on to do other things. So it should be a win-win by becoming a conduit for the developments going on at EMBL and in other places that can connect to the imaging center and see the technology being put to use. And so I hope this will be happening more and more in the future. We have already started with the system, but I wanted to just explain this a little bit here. This, I think, is also interesting if one thinks about working with industrial partners. And as I was already mentioning before, we already have several of them. And here the idea again can be that by providing dedicated service, one can bring, or one can make more of a joint and of an integrated development, and providing application testing earlier on, and by this bring the scientific impact of a new technology closer already into the field as is possible in classical service schemes. So what we're aiming for is a new model of of interaction with the companies and also of user support, where in the form of open innovation, one can work closely with companies and then provide solutions before they really reach the market in a controlled manner that is okay with the companies, and by this just speed up the whole process. So we hope that we can be a very good testing environment for new imaging technologies, and that we can do this also in a balanced manner with multiple industrial partners, as we're already starting now. What will be also very important, and I think this is a fundamental strategic consideration, is that since there are two groups and two service teams in the same building, focusing on really the latest technologies, that we bring those together. So correlative approaches between light and electron microscopy, especially in the cryo regime, will be extremely important. And I think we have the critical mass to really make a difference here. And this is where we're going to aim after setting up our groups at the highest possible levels, to then correlate this and to develop new technologies and also provide the project all the way through to the integrative data analysis. Having said this, I am now going to look a little bit into the services that we will be able to offer already in this year in 2021. So we will aim to cover different resolution levels, work with different technologies that also work at different throughputs, with different sample properties, so different thicknesses, and of course also with fundamental different principles underneath this in the form of labeling, so that we can really make use of a lot of currently advanced technologies. So systems that we're setting up at the moment, and at least two of them I will also on highest resolution. This is given because if we want to connect efficiently to electron microscopy, we want to, of course, do this at the highest possible resolution that is available on the light microscopy side. So super resolution, which is also, of course, a very hard technology to offer, which, depending on what kind of solution one is choosing, requires a lot of expertise in the execution, is something that I think is very suited to be offered inside the imaging center. And this is something for the different modalities that are there right now for STAT, for single molecule localization, for MinFlux. We will also extend early on to multiphoton microscopy, fluorescence lifetime imaging, and we're also currently setting up the planning for a light sheet microscope that will also be part, custom light sheet microscope that will be part of the service offer, hopefully still inside this year. This will also be supplemented by a range of high-end instruments from our industrial partners, so the MinFlux, of which I'm still going to talk a little bit, as well as high-end instrumentation from Leica, where the latest range can be offered also for service with the users inside the imaging center. What I want to show, because this should be the example on which we are focusing more and more in the future, is, for example, the setting up of technology that is being developed inside EMBL, in this case in the group of Jonas Ries, which allows us to set up high-end solutions, in this case for single molecule localization, inside the imaging center, which are not a commercial solution, but which are then very flexible. So which are, of course, first of all, very robust, very stable, have very good illumination control, stabilization, and can be used for multicolor imaging. And all of this at the highest level, the whole thing then controlled inside Micromanager to allow also maximum extendability and flexibility also for the future. So this is right now set up by Rory, so the engineer in the group, and is, as I said, based on different approaches that have been developed in Jonas' group, and where we can maybe really be the conduit to provide a service-ready system that can make use of all these technologies and inputs. The other thing that I wanted to simply released by Aberio, and actually the one that we have was the first system built by Aberio, and I think because it's a very still new technique that also requires a lot of expertise, this also makes sense inside the imaging center, because it really requires, I think, or it can really profit from excellent support. So this is something that Sebastian has been doing. He has been really setting up the system. He has tested the performance, he has optimized the room, and this is something I wanted to show here. Since we have really a whole center that we can set up, we subdivided the room for more temperature stabilization. So all the heat generating elements actually went into a separate room with its own heat extraction. And we are still in the process of optimizing the room and isolating it from vibrations as much as possible. So clearly on the concrete slab, we don't have external vibrations, but we can still get something through sound. So we are getting rid of any kind of disturbance, and we get very good results, as you can see here in the image, that we can then also offer to external users. We show this here in the form of an application example. So taking nuclear pore proteins as a macromolecular complex, you can see that the resolution that you get with the system and that can then be offered really as a service is quite outstanding. So in the range of, you can clearly separate structures that are 10 nanometers approximately apart. And again, we can, of course, on these technologies also work together with developer groups, in this case, again, Jonas, to optimize the system and develop the methods further. So I think all of this can really be operated as a win-win, which then allows you to really offer technologies at the latest level. On the electron microscopy side, we are also starting services. These will be maybe not so much on instrument development. This is not the way that it works in electron microscopy, in cryo-electron microscopy, but you need a lot of expertise to actually provide interest in the biological projects that are needed. So in this case, single particle analysis will be very important. Cryo-electron tomography in situ, which can be done by lamella, for example, and of course also to correlate this to light as well as electron, so to do cryo correlation between light and electron microscopy. These are the aims of the services on the EM side. And also there, a lot of equipment, as I said, is already in place that will allow, with cryo sample preparation devices, where we will have the full range available for user projects, cryo transmission EMs, FIP scanning electron microscopes for ablation, and also serial block phase scanning. We will be able to correlate light and electron microscopy and also to create complex 3D data sets. So all of this is in a way right now starting up. And this should be shown here in the timeline. It's been planned from 2015 on, and I think the technical planning was really, really important before even starting building. We are now on the phase where we're testing user projects, and the building will be fully opened just around now. And we will make an open call for user projects to really be open to the outside in autumn 2021. Just maybe to show, and again, this is more of a technical consideration, and I'm almost at the end of my talk with this as well. The idea how to offer a service goes, of course, through different stages. So we have to develop these technologies to the service level, as can be seen here. And this is done with collaborative projects initially, then, and this will be repeated and repeated with every technology, with invited external pilot projects, and will in the end, of course, then be open to service and will be operated through open access. So these phases will be important to actually provide a service as good as possible and using the structures of the teams that we are creating. So this is here the last slide, which I just spent 1 minute on. And these are just operational considerations, because for me, it was extremely interesting to deviate from something I'm fairly familiar with, which is facility operation, to something new. And I just can restate that what we're aiming for is not a core facility. And for those people from EMBL and my former colleagues and the people I know very well, of course, not the ALMF2. The purpose of what we are just describing is completely different from what is mainly what is covered by core facilities. They work on different requirements, and we have, of course, huge overlaps. And ideally, everything is just used most efficiently inside an institution as one thing, but this is not the same thing. So the focus is very strong to the outside, and that is different from a core facility. A core facility is something that is part of the institute and that grows outside of the institute and then grows out and can service externally. In this case, this is something that is set up as a separate unit. It doesn't have to be complete. It has to be, to make the most use of new technologies, it should be specialized on these technologies. But of course, it needs a full support structure to actually run, to be able to handle these experiments. One has to think more in an integrative support process. So the user project support, which is different from providing an instrument for booking, for example. Also, on training and outreach will be very important, but it will be more on the technologies and not so much on the instrument, because people visit for the projects, but you do not really, it doesn't really help to train people if they're not coming back to reuse the instrument. So there are just a lot of differences. It should be a unique infrastructure. So we have to avoid focusing on things that are done well in other places. We should connect to developers. We should connect to technology providers. The technology needs to reinvent, the portfolio needs to reinvent itself continuously. So there should be a huge turnover. And we don't have to aim to provide services in confocal microscopy, even though, let's say, confocal microscopy is very important, but it is locally provided in almost any place. So we have to really focus on the latest technologies. And we should, of course, play to our strengths. In this case, the complementary element EM teams. So we should really develop a very good offer for correlative approaches. It should be something that is done over many years. So it should grow out sustainably as a service offer. Quality of the service offer is absolute key. So we should not rush things, but we should do them right. Test and abort technologies before they're included in the service. And expand and replace instruments and services. In this case, and that's again something that I think is very different to almost any building I've seen, we should be able not to be driven by space limitations. At the moment, we can really grow into the building and we don't have to worry about having to swap out instruments if they are needed. So I think there's really a lot of potential to do this right. Since Ulrike was mentioning this in the preparation of the talk, I just also thought, okay, and what's the recognition and the benefits? So how can one actually then justify such a structure? Some of it will be easier because I think visitor projects and that are coming with already fairly progressed projects, they are easier to recognize. So I think recognition in the form of papers is actually easier to track than for many core facilities. But on the other hand, of course, there will be a lot of also really large-scale strategic considerations where also the stakeholders have to really understand what is the value. So one has to really think also at the global level, because this has to really work for the people that are supporting it. And it will have to be in multiple evaluation areas. So you cannot only, for example, reduce it to the financial aspect. You can only reduce it to the technological aspect. All of it has to be a mix. And even for a core facility, I never found a good single indicator. But I think what we have to aim for is something where clearly people would realize, okay, if it's not there, we're worse off. And that's something that then allows you to actually represent or to operate a successful, in this case, imaging center. Okay, that's it from my side. I went a bit over time. I hope it's fine. I'm really excited about the new project. I would really like to thank the people that spent now years to organize and to plan this. We had excellent project support by the program manager, Steffi Alexander, and also by our scientific service support manager that is now setting up, Judith, and also administrative support. You see the teams, thanks to the people that made it possible, like the different funders. As I said, right down to Heidelberg Cement, because 900 cubic meters of cement are not easy to obtain, and they're missing in other buildings right now. And of course, our industrial partners that I was already mentioning before. Yeah, thank you.
Okay, thank you, Timo. Really interesting talk, and it's quite impressive to see how much thought and dedication went into the whole planning of the center, and to actually see it come into operation later this year. So thanks a lot. I'm sure there's many people here that are interested in imaging and have questions. So if you have, please raise your hand, or otherwise just turn on your video and raise your hand this way, so I can identify you. And maybe while people think about questions, a kind of a general question I have is like, how will you or the imaging center in general decide on which new technologies should be implemented? You know, how do you plan to gauge the interest from the community? Will you do this through surveys or how will you reach out to potential users?
On the specifics of the answer, one has to distinguish, for example, between EM and LM. I think they play by different rules. Maybe I'll focus right now just for conciseness only on the LM side. But there will be an advisory board. I think it will be very important to talk to really technology developers, but also to, so this is something we're setting up right now, where people could be asked for their opinion and can provide ideas. And I think this can be supplemented by just also being very sensitive, but we could also network with the bigger infrastructures. For example, EMBL Imaging is, of course, doing very, very similar evaluations. And if we connect correctly to them, we can, of course, also harness this, because I think doing redundant surveys may not be so important as reading the right surveys as they're being done. So in this case, I think we would rather see ourselves as part of a bigger fulfilling certain needs that others may not be able to, because it shouldn't be a competition, it should be complementary. But at least these two levels.
Okay, yeah, thanks. Any questions from the audience? Yeah, Mark.
Hi, yeah, I guess one question I had to go along with Robert's question was, how long were you committed to sticking with this certain technology? Because it may come that either something becomes more obsolete or maybe something just becomes widely available and commercialized, but users might need to come back at a certain point. So how long are you committed to keeping a certain technology around?
That's a good question where I will not be able to say a single number, but I think I already tried to raise this a little bit. I think any of you that is familiar with, let's say, imaging core facilities will realize that a lot of their offer, or where the most usage is being generated, is not on the cutting edge technologies. If you just reduce it, for example, to commercial consideration, what you mainly are using are the confocal microscopes, maybe even the wide field systems, high throughput systems. And these are also the ones generating the revenue. So you very often, if you want to provide very good advanced service, you just have to say, okay, in addition, whenever somebody comes, we have to be able to do this and this, but it's not like people are doing FCS 365 days a year, 24 hours. So if you would just do it by demand, you are stuck on providing technologies that you maybe personally do not find challenging, but they are extremely important to the field. If you now think about a structure that doesn't have to do well what others are doing, then we have to do two things. We have to let go of technologies that are becoming established, and of course there's a timeline, and replace them with new technologies. This will go much faster than, let's say, as I said, if you think about a normal imaging facility, because you are not bound to this as a completeness of offer. What this will mean in practice can be in the range of years. I think what helps there also financially is, of course, that you can you should generate, having a host or a range of development systems, then adapting those and following the technology should be also the way to go. But basically the evaluation has to be, is it already common? Then it should not be your focus. It's just, you lose your energy, and then you have to see what else you can set up instead.
Okay, yeah, I hope that answered Mark's question. Are there any others? Yeah, Ulrike?
So maybe about the cost factor for every individual project when someone wants to use a specific microscope. So you said that parts of the cost will be covered, but also other parts might not be covered. Is there an option maybe to request European, like short-term funding by the European Union or things like that? Because I know that there are these funding options available. Because the problem is, if the project really takes a bit longer and the scientist, for example, has to stay there for half a year, then the hotel costs need to be financed, travel costs need to be financed to a certain extent, which actually is quite a burden on countries or institutions which don't have so much funding. So is there an option to maybe buffer these costs as well to a certain extent?
Yes, so I think this varies, of course, from continent to continent in this case. I think a lot of improvement is still needed in this, but there are at least some access funding schemes, and they're very often also associated with infrastructures. And I think these will be essential to be connected efficiently so that people can know about them and can use them to apply, for example, to the imaging center. So I think funding, they are more familiar right now with the structural biology side. So I think Instruct, for example, offers access funding, as well as INEX Discovery, and these will be more and more important. Or one has to also start to operate more like infrastructures like beamlines that are also depending that people can justify their projects based on the technology they want to use. And this will be also the challenge for the imaging center. But some are in place. My personal opinion is more are needed, because one thing I think that, let's say, operation of core facilities has shown, of course, in the end, you have to spend much less money on a centralized structure where you can provide a service. And if you now extend this to high-end services, the same goes, even including traveling. Instead of having to replicate structures all over the place, you should make those that you have efficiently accessible. And I think there's right now a lot going on at the national level, partially. I saw it also in Spain.
Yeah, Ulrike, did this answer your question? I think so.
Yeah, thank you.
Anyone else? Yeah, Anik.
Hi, thanks for your talk. I was wondering, at what point would you expect or hope that scientists come to you with their project? Because you're talking about this whole integrated project management, where you really go from the start to the acquisition to the data analysis. So is this really at the point where people, where, you know, I have an idea, but I know nothing about imaging, or should I already know, like, I want to do this and this and this? Can you help me execute it in the most efficient or smart way?
Yeah, no, that's a very good point. For the techniques that we're aiming for, probably starting at zero is not the point. You can assume that at least there should be a good basis of light microscopy data and experience in what could be done for your own science with getting more of those data. So this will be done through both a technical evaluation as well as a scientific evaluation. And I think this is important, but just to say once more, I don't think that this is now meaning you can do everything for a person that had not already put a lot of effort into their project. You can just give the last push for a fairly mature project.
Okay, clear. Thank you very much.
Okay, great. So we are coming close to the hour, so maybe one last question, if there's any. And if not, then maybe Timo, can you give us a concluding estimate of how many users or how many projects the imaging center will be able to handle at full operation? What type of scale are we talking about?
That's a hard number. I think there's an aim, and I have noticed that people that planned this, of course, have put quite some experience in. I mean, we can probably really handle quite a lot. Whether the 300 users that are mentioned, they will not be reached in the first year. In the long run, and growing into the center and into the size of the center, and let's say growing out the service model correctly, I think that is feasible. One thing that also that we are affected by right now, I didn't even mention this through the whole talk, is of course we are all right now in the Corona situation, and now talking about open access and people visiting is maybe not the thing. We are of course also right now working a lot with remote samples. That also works for these technologies. It's quite established, of course, in electron microscopy, and taking this on board as well, of course, the throughput can be quite significant. So I would say in the range of a good-sized facility that works internally is something that is possible with this kind of center. Also, if you look at the number of staff and at the level of support that we can provide.
Okay. No, yeah. Thanks a lot, Timo, again, for this really interesting talk. So I guess this concludes the seminar for today, and maybe I switch on my video again. So maybe I hand over to Ulrike now for some concluding words and some outlook for the next seminars and how we continue after the summer.
Yeah, so first of all, thank you very much, Timo, for this very insightful presentation. I think the center will be an amazing enrichment for the imaging community, not only in Europe, but also worldwide. So with your final presentations also, so that the second series of our combined imaging series goes to an end, but that doesn't really mean that our series is over because Christian, Robert, and also Chen and the others from the organizing team, we are already eager collecting new or setting up a new schedule for the third round. And with the third round, we also will have a few new things which we implement. And one of these new things is that we plan actually to have half an hour of an extension after the talk for in-depth discussions. So if we have a speaker, or if you have a topic which is very much of interest for you, you would have the option to maybe indicate this to one of the hosts of the sessions ahead of time, or even while you watch the presentation, you can also mention this in the chat. And then you would have the option to ask very in-depth questions, for example, how specific parts are being built, or how to integrate certain labels with your specific structure, and whatever crazy in-depth questions you might have, you would have the option to extend this or to ask these questions in the extended 30 minutes after the presentation. And I hope this also might not only answer your question, but hopefully also stimulates a bit more collaboration also between our two institutions, and a bit more exchange. So this is really something to very much look forward to, I would say. But with that, I can already actually announce the next speaker for September. So Isabel Espinosa Mendina, who's a postdoc here at the Genela Research Center. She will kick off the third series with the talk called Temporal Encoding and Manipulation of Vertebrate Cell Histories with a new CRISPR-Cas9 system. So that's actually a very nice method in order to track the cell heritage with new markers she developed here at Genela. So this is actually a super nice technology, and she's also an amazing scientist. So that's really something to look forward to. And her presentation, or how can I say, our next meeting will then be on September 7th at 9 a.m. Eastern Time / 3 p.m. Central European Time. And yeah, we're very much looking forward, and I hope you too as well. And with that, I just only say last word. Thank you very much, Timo. Thank you very much also, Christian and Robert, for helping with the organization of the entire series so far. And hope to see you in September then. Bye-bye. Bye.